Okay, good morning, everyone. So, welcome to the pre-recorded lecture on 16th of October 2020 for Geology of Fuels, and we have been discussing about uh, coal geology, and today we are going to look at the typical depositional environment required for the formation of coal. Okay, so okay, just let me fire up the presentation. Okay. So here we are going to look at what are the basic conditions which are required for the formation of peat. Okay. So as you know that peat is essentially the first step of the peat is the first step of the coal formation cycle, right? So where would you form? What are the conditions? So what we are going to look at, what are the conditions which are necessary for the formation of good amount of peat. Okay. So as we said that the peat essentially forms in a deltaic environment. So now if we try to get into bit more details about the typical conditions that you would require for the formation of peat. Okay. So the first thing that we will need is a specific type of climate. A climate that allows high rainfall or humidity to support luxuriant plant growth. Okay? Because you need to have a lot of plants growing there, which would essentially die and form peat, right? So a climate is required which supports the booming of plants. Okay? So that's the first thing. The second thing, you need a slowly subsiding basin. What slowly subsiding basins do, they essentially create a lot of accommodation space, and those accommodation spaces are filled by these precursor of the pit, yeah, and then they get slowly covered by shell, and then eventually that forms pit. So you will require a slowly subsiding basin. The third, you will not appreciate to have a lot of heterogeneous influx into your slowly subsiding basin where peat is being formed, because it actually first of all it creates an oxic environment because of the churning that happens due to the presence of such heterogeneous impact. And by heterogeneous influx, I mean that there must not be a lot of rivers in that area where the peat is being formed. Okay. And the second thing is, if you have a lot of heterogeneous influx, what it would do, it would essentially put a lot of inorganic material into the basin. Okay, so that will decrease my accommodation space for the organic matter. And secondly, if you think in terms of the coal quality, it will also increase the number of partings, and hence mineral matter, the ash content would increase. Okay, so the clastic sediment, which there should be very low amount of clastic sediment influx into your basin where peat is being formed. And the last but not the least, you need a reducing condition, reducing environment, because if it is an oxic environment, what would happen? All the woody material which is being accumulated will be essentially decomposed. It will not be preserved and decomposed into carbon dioxide, right? So you don't want that to happen. So you need reducing condition as well. So this is a typical accommodation space of 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 pit. Okay? So consider this to be like a delta in a deltaic environment, and then part of the delta, yeah, which is high lying part of the delta. What would happen there? There, the peat accumulation rate will be more than the rate of subsidence in the proximal part proximal part of the delta. which is more towards the land, the peat accumulation rate would exceed the rate of subsidence. Okay. And in the distal part, what would we see? That the subsidence rate will exceed the rate of peat accumulation. Okay. So what this would essentially, this part of the environment would essentially make sure that there would be little or no peat preserved because of the lack of cover. Because if there is no subsidence, it will not be able to cover it up, right? So subsidence is necessary, and that has to be more than the peat accumulation rate, and that happens in the distal part. Okay, so of course, there would not be a good coal formation in this part, but in this part where the subsidence rate is more than the peat formation, there would be good coal formation. So these are the basic conditions that you will require for the formation of peat. Okay. So now, if you want to, we know that the present is the key to the past. If we look at the present day peats, okay, this is how it looks like, and this is what would essentially form a typical coal reserve, right? But remember, you can see here there is a channel as well. There is a river flowing through the delta, and very close to this river, perhaps the coal formation will be hampered. So you have to go away from the river. Okay, but this is a typical setting which would essentially form coal in the future, right? This is an example of the Cooper River Delta from Alaska. So now, if you look at in the world where such peat accumulation is going on, you can see, for example, in India, in the Sundarbans and in the Andaman Sea, you have a lot of peat accumulation in the deltaic setting. But you can also observe that this is not only restricted in the low latitudes or in the tropical areas. You also have peat formation in the high latitudes. Okay, both in the northern hemisphere as well as in the southern hemisphere. You do have your peat accumulation at the higher altitudes too. Okay. Now, these are some of the examples where peat accumulation is going on. For example, from South China Sea, from Hudson Bay, from Kara Sea in Western Siberia. Hudson Bay is in Canada, and South China Sea is, of course, in Malaysia and in Indonesia. What you observe, so the black color in here represents 75%, more than 75% peat. The gray color represents 55 to 75% peat, and the white color with this inverted triangle represents less than 55% peat. But if you want to and if you look at the scale, this is like 5,000 kilometer, this is 300 kilometer, sorry, 500 kilometer, 300 kilometer, this is 1,000 kilometer, and you can imagine that the size of this peat accumulation is not bad at all. It's really, really extensive. So if this coal, after being compacted, forms coal, it will be of significant volume, yeah, in future. So these are some of the plant material that you observe in a typical wetland. Okay? You can see, although it is in wetland, the plants are fairly tall and it's fairly woody. But then, if you are closer to the water body, what do you see? That the plants are essentially shrubby. They're small, they're shrubby. This is called a oligotrophic bog lake. Yeah. And these are highly tall trees in the wetland. Okay. Now this will be both of them would clear. Both of them will essentially create some sort of coal, and how we will look at it. Okay, so geographically, if you look at this, this is a delta, of course, and in this delta we are looking at somewhere here, right? So in here you can see this beautiful um, Krabi, the presence of a bog lake, okay? And a few meters away from the from the shore of the bog lake, you see these wetland where you have longer or taller trees. Now, if we now suppose, so this is that bog lake which we have been discussing, and from that bog lake or the moor lake, we are essentially going more towards the land. Okay? This is the environment we are looking at. More towards the land, we will find four types of vegetation, which is completely at the proximal part. I mean, away from the lake, that we will call as dry forest. And then there will be a place where there will be some water, which is occasionally inundated by the lake water. That is what we call as the wet forest. And then the reed moor, where you can see obviously it's more shrubby plant material. Okay, and then Moor Lake. Okay. Now let us look at all these types of areas and see where would I form the best quality of coal. Okay. Now, if we look at the dry forest, so there is no water cover there, right? Very little water cover, maybe at a maybe once in 50 years or so, when the lake is completely flooded, there could be some water cover, almost none. Okay, acidity very high. Atmospheric oxygen, yes, it is presented. Chemical reactions that you will expect here is oxidation. Organic activity, fungi, insect, aerobic bacteria. And what would that do? That would essentially decompose your plant and it will rot your plant. Okay? Pit type is woody with resin bodies. But then, because it is completely oxic environment, although I have a lot of woody material present in the dry forest, they will not create good amount of coal or abundance in coal. If a little bit of coal is formed, that the primary lithotype that will form in this type of environment will be fusion, which is fibrous coal with some duran, which is called dull coal, which is not a good quality coal, right? So you can see here, obviously, if this is the accommodation space for the formation of peat, right? You can see for the dry forest, it is fairly limited. This area is fairly limited, right? And this is, of course, will not going to create a lot of good quality coal. Now let us look at the wet forest. Okay, what would happen in the wet forest? Wet forest would have oscillating water cover. Water cover means the sediment will come and essentially mask your peat accumulation by uh, dropping shell covers. Okay, and that will kind of stop. I mean, create that anaerobic environment. Okay, so water cover is oscillating, acidity is medium, atmospheric oxygen is partly present. Yeah, chemical reactions, both oxidation and reduction. Organic activity, we both have aerobic and anaerobic bacteria here, and this is the main zone for petrification. Okay? This is the main zone of petrification. What sort of coal would you form here? Vitrine, Claren, Duroclaren, bright coal, banded bright coal, banded coal. So this is the best place, in my opinion, to be the formation of coal, to be make the best quality of coal. Okay, this is the best place. Now, if we go even more distal in the Reedmoor area, atmospheric oxygen is almost absent. Acidity is low. Water cover is complete. I mean, it is always. Almost complete. It is most of the time below the water. Chemical reactions, mainly reduction, and mainly anaerobic bacteria. This is also a main zone of petrification. But because of this plant material, which is not as woody as the wet forest, you will generally form uh, cleroduran or some duran, dull coal, banded dull coal. Okay? So this is my, it's not as good as the wet forest, but this will also create a good amount of coal. If we go more distant, then Moor Lake, which is quite into the lake. Okay, water cover is complete, acidity is low, atmospheric oxygen is absent, chemical reactions only reduction, organic activity only anaerobic bacteria. Okay, pit type is organic mud. This will form Duran or dull coal, canal and boghead coal, which are like sapropelic coal, non-banded at all. But this can form oil shell, coal oil shell. Okay? So this is that. Is that. So the best quality coal I will still find here, okay, where my wet forest. So ancient pit belts. How do you know where my ancient pit belts were? You just look at the today's you know coal deposits, right? So the coal deposits, whatever are present today, they were your ancient global pit deposits, and you can see coal. I mean, they are all. I mean, you have to do a little bit of plate reconstruction to know where they were during the formation of coal, and you can see both tropical as well as subtropical and high latitude um, stuff has actually made coal. Okay. For example, Gondwana coals, which is currently in the tropical environment, were not so tropical when it was in the Permian age, because the Gondwana coals are mostly Permian coal, right? So they were more high latitude coal. Right? So the moral of the story is it essentially forms, as we have seen in the present, both in the higher latitudes as well as in the lower latitudes, also in the geologic past. It's a picture of the Gondwana land at that time. Now, geological distribution of coals in India. So there are tertiary coal fields in India. There are upper Gondwana coal fields and there are lower Gondwana coal fields. So the tertiary coal fields are early Pleistocene to upper Pliocene and Miocene, and then they are essentially forming lignites of the Kashmir Valley, okay, which is called Ichahome lignite, and the lignites of the South Arcot, Tamil Nadu, Barkala, and in Kerala. So that's my the most true. I mean the youngest lignite deposits that we have in India. Then you have Oligocene to Upper Eocene lignites like Jaipur, Nazira, Makum coalfields of Upper Assam, Namchik, Namphum coalfields of the Arunachal Pradesh. And then Middle Eocene, lignites of Alana, Rajasthan, lignites of Kutch, also fairly big lignites of Kutch. And then Lower Eocene, coals of Darangiri, then Garo Hills, coals of Cherrapunji, okay, Meghalaya, Miki Hills of Upper Assam, coals of Jammu coalfields, Kalakot Meta, Mahogala, Chakradhangal, Salakot, Lodhra, Purachinak. Yeah, these are all mostly in the northeast. Then so this is the tertiary coalfields, and then of course we have the upper Gondwana coalfields like the upper Jurassic coalfields. Yeah, Chikala, Kota, in Maharashtra, in the Satpura region, in the Jabalpur state, Madhya Pradesh, Guneri, Kutch below Umari, below Umia stage. Okay, these are the places where we have Upper Jurassic coals, and then we have the Permian coals, which is the largest coal deposits in India. The Upper Permian, Raniganj, Jharia, Bokaro, Karanpura coal fields, the Damodar Valley of West Bengal and Bihar, and the Lower Permian, all Gondwana coal fields, including Peninsula, including Damodar Valley, Mahanadi Valley, Brahmani Valley, then Son Valley, Pench, Kanha Valley, Ranita Godavari Valley, Wardha Valley, coalfields of Eastern Himalaya, Darjeeling district of West Bengal, Rangit Valley of Sikkim. In all these places, you find lower Gondwana coalfields. Okay, so basically, we find coals in three basic areas, three basic time periods in India: tertiary coals, upper Gondwana coals, and lower Gondwana coals. Upper Gondwana coals are mostly Jurassic coals. This is a good thing to actually at least have few names remembered for each time period. Okay, at least the major ones. Okay. Now you can see a coal seam from Trinidad. You can see a beautiful fault present in that coal seam as well that has displaced the coal seam. So normal fault was first described in a coal mine. Okay. So what essentially happened that they were tracking some seams, okay, in a coal mine, and then all on a sudden they saw that this coal seam has abruptly stopped, and then after a while it started again. So it has faulted, and they used to always see that it is going down. Okay, and so hence they called them as normal fault. That it's normally found, hence they are called normal fault. This is a typical normal fault which has displaced the coal seam. Now here the coal seam is extremely deformed, as you can see. That if I draw the out layer of the coal seam, you can see it's extremely deformed, folded, faulted, thrusted. Quite a lot of things going on in this coal seam. Very, very deformed coal seam. Yeah. What is the significance of deformed coal seam? We will discuss later in the in coal bed methane. These are typical low dipping coal seam, as you can see, with intermediate non-coaly layers. Of course, here a coal seam is shown. You can see the coal seams are of different thicknesses, which is kind of and dipping, and then has been dissected by a fault. Okay. This is the deep direction of the coal seam, and they are of different thickness. You can see here these coal seams are penny-contemporarily deformed. Okay, so during the formation of the coal itself, they are kind of folded a little bit. You can also find boudinage here within the coal, the boudinaged, and they are little bit deformed. They are perhaps this is perhaps penny-contemporaneous deformation by the look of it. You can see another coal seam, and this is from a mine itself. The way the mine map of a coal seam, of different coal seams, and you can see how extremely deformed they are. You have anticlines, sharp anticlines, and then you have synclines. So very, very well deformed uh, set of coal seams. Okay. You can see here also the coal seams are very, very deformed. Okay. And such a beautiful structure it had formed. This is the this is inside a coal mine where long wall coal mining is going on. You can see people here working. Okay, and these are the railroads which actually take the coal from the mine itself, to near to the shaft, and then from the shaft it goes up. Okay, and the next picture is of a coal shaft. Of course, people are getting down, okay, to work inside a coal mine. This is the vertical shaft, and this is a typical picture of a coal seam which is split. Okay, you can see here that the coal seam is split. So the it's like the because of the change in the depositional environment, this is perhaps more distal, and this is more proximal. So all these beautiful sand lenses indicate that these are the time when when the land essentially, I mean the sea or the water body went away from the from the peat accommodation space. Okay, so these formations are all typical regressive cycles. These are the time of regressions. That is what generally causes coal seam split. So you don't, so you can see these seams are essentially merged together to form a single coal seam. And seam split in coal fields are very common. Okay, so I will end the lecture here, and I will see you then next week. Thank you very much.